Hello everyone. So in today's tutorial we will be discussing the very last topic of chapter 5 of class 10, that is the nature of oxides. Okay, so we have discussed many trends till now along a group and along a period in the modern periodic table, like metallic character, non-metallic character, then atomic radius, valency, valence electrons. So now we are left with only one trend or the behavior, that is the nature of metallic oxides. Okay, so today we will be discussing this topic in detail. So let us now understand that what are metallic oxides or what are actually oxides. Okay, so oxide means that it is the combination of oxygen with an element, minimum one oxygen. Okay, so whenever oxygen combines with any element and it forms the combination of that element with this oxygen, so the compound hence formed is called as the oxide. Okay, it can be a metallic oxide if this element is a metal. It can be a non-metallic oxide if this element is a non-metal. So oxides of metals, whenever any metal, it will combine with the oxygen, right? So the oxides of metals, like if I'll just tell you the oxide of sodium, which is Na2O, so the oxides of metals, they are basic in nature, right? So it means that if we will dissolve this oxide into water, the resulting solution will be basic in nature, that is its pH is going to be more than 7, right? And when we talk about the non-metals, like suppose I talk about sulfur, so the oxide of sulfur has the formula of SO2. There can be some other formula also like SO3. This is sulfur dioxide and this is sulfur trioxide. So it can be it is acidic in nature, right? So the oxides of metals, they are basic in nature, the pH is more than 7, and the oxides of non-metals, they are acidic in nature. But here we need to understand one thing, that there are certain non-metallic oxides which are neutral also. Okay, for example, like the oxide of hydrogen, which we generally call as water. So water is neutral, right? And carbon monoxide, which is the oxide of carbon, and the oxide of nitrogen, which is nitrous oxide. So these are three examples of those non-metallic oxides. These are non-metallic oxides, but they are neutral, and the pH in these cases is going to be 7, right? So let us repeat this once again. Metallic oxides are basic in nature, their pH is going to be more than 7. Non-metallic oxides will be acidic in nature, their pH will be less than 7. Okay, and some of the non-metallic oxides are neutral also, right? They are neutral also, and in this case the pH is equal to 7. Now let us understand that how does the nature of oxide, it varies along a period, right? So let us take the example of third period. The third period elements, like the oxide of oxygen is Na2O, then magnesium oxide is MgO, then aluminium oxide is Al2O3, then silicon oxide or silicon dioxide is SiO2. Then moving on to phosphorus, the formula is P2O5, right? Then moving on to sulfur, we are taking just sulfur dioxide as the example. Then moving on to chlorine, it is Cl2O7. And since the last one over here is argon, so let me make it clear that argon is a noble gas, so it doesn't react easily, so it doesn't form the oxide also. Okay, so now let us see the trend. So over here, sodium oxide and magnesium oxide, they are the basic oxides. So what does it mean? That on the left hand side of the periodic table, the oxides, they are going to be basic in nature. Then we move on to aluminium. Now aluminium forms such oxides which comes in a very special category, and these oxides are called as amphoteric oxides. Now, what do we mean by amphoteric oxides? That these are those oxides which possess a dual nature. They can behave like acidic as well as they can behave like basic oxides. Okay. So we can say that they form a borderline of the oxides. They form acidic oxides as well as basic oxides. But now when we move on to silicon, so silicon, it forms weakly acidic oxides. So can we see the trend that initially it was basic oxide on the extreme left hand side? Then came the aluminium. Its oxide is at the borderline, that is, it can show the basic as well as the acidic behavior. Now moving on to silicon dioxide. So its oxide is weakly acidic, that is, its pH is now decreasing from 7. Okay. Now when we move to the oxide of phosphorus, that is phosphorus pentoxide, its oxide is acidic. It's not like weak, but it is acidic, like it's strong enough, right? Then sulfur dioxide, it is a strongly acidic oxide, and we all know that in those cities where we have excess of air pollution, this gas is always present in the atmosphere, and whenever it rains, this gas combines with the rainwater and it results in the formation of acid, and that rain which contains the acid is called acid rain. So I guess that now it is clear that why that rain becomes acidic, because this oxide is acidic in nature. And when we move to the last one, that is chlorine, so this one is a highly or very strongly acidic oxide, right? So what is the trend? So can we say that when we move along a period from left to right, on the extreme left corner, the nature of the oxide is basic. Then in case of aluminium, it becomes amphoteric oxide, both basic and acidic. When we move to the right side till group 17, it becomes acidic, and group 18 do not form oxides at all, right? So this is the behavior in case of a period, right? Now when we talk about a group, now we have discussed the period, now let us talk about a group. So let us talk here about group number 2, right? So we can see that there are so many elements like beryllium, magnesium, calcium, strontium, barium and radium. And if you have watched the previous tutorial also for the metallic character of elements, so we know that down a group the metallic character of elements, it increases, right? So now just correlate this metallic character with the nature of oxide over here. So can I say that the metallic character increases down a group? Hence, the basic nature of the oxide will also increase. Now suppose that if I'll give you one case or one example just to focus on this highlighted portion. Okay, magnesium, we have calcium, strontium and barium. So we know that out of these 4 elements, barium is the most metallic, right? In the previous tutorial it was made clear, right? So we all know that barium is the most metallic. So can we say that barium oxide will be most basic also? So the answer is yes, because we now know that metallic oxides are basic in nature and their pH is going to be more than 7, right? So this is what we have discussed in today's tutorial, and with this topic the chapter comes to an end. I hope you've understood the entire chapter. If any query, please let me know. Thank you.